today we will talk about the deep learning topic called convolutional neural network. So the question arises here, what is convolutional neural network? A convolutional neural network is a network architecture for deep learning that learns directly from the data. Data can be anything, whether it is text, voice, speech recognition, or object classes. Anything we can use it as a data. So it is a subset of machine learning, we can say CNN. CNN is one of the various types of artificial neural networks which are used for different application and data types, we can say that. So we have to understand that neural network architecture conventionally used in computer vision. Computer vision is a branch of artificial intelligence that enables a machine to understand and illustrate the image or visual data. Now, let's understand how many types of layer present in the CNN. Basically, there are three types like input, hidden, or output layers. In hidden layers, there are 2 to 3 layers we will discuss later. Here we will discuss about the CNN architecture. So as you're seeing in the slide, we having image as an input, then we have added 2 convolutional neural network, convolutional layer, then max pooling, then dense layer we have added, and after that we have output, or we can say output layer. So what inside it, let's discuss about it. That CNN consists of multiple layers like the input layer, convolutional layer, pooling layer, and fully connected layers. Alright, so let's talk about the computational layers. Applies filters to the input image to extract the feature from the pooling layer. From here we have extracting the features, and then we downsamples the images, means we are compressing the images to reduce the computation. It will also reduce the computation cost and size, and fully connected layers makes the final prediction here. This one is here, it is making final predictions. The network learns the optimal filters through backpropagation and gradient descent. The question arises here is how convolutional layer works. Right. So a convolutional neural network is a neural network which shares its parameter. As you can imagine, an image of cuboidal shape having its length, breadth, height, which is shown in the figure. You can see it as having height or length and breadth. Now, what is RGB? RGB is the color, highly saturated color. Other colors are less saturated, but RGB are highly saturated. R stands for red, G for green, and B for blue. The question arises here is how convolutional layer works. Right. So a convolutional neural network is a neural network which shares its parameter. As you can imagine, an image of cuboidal shape having its length, breadth, height, which is shown in the figure. You can see it as having height or length and breadth. Now, what is RGB? RGB is the color, highly saturated color. Other colors are less saturated, but RGB are highly saturated. R stands for red, G for green, and B for blue. Now we will understand by calculating it mathematically, we can say. Let us consider a little patch of above images figure and running a small neural network said to be filter, or we can say kernel on it. Now K is the output and presenting them vertically. Now we can slide the neural network across the entire image, concerning that we will gain as pair images having different height, width or depth. Rather than RGB channels, we have another channels. As I have told you that highly saturated channels are RGB, or less saturated channels are like pink or violet. So this process is known as a convolution. And patch size remains same as the image size, then we consider it as a regular neural network. Just because of patch, we have some extra work. So here we are seeing cuboidal shaped, having height, length, or breadth. RGB channels are also present here, and there's a projection. I think it is showing. Yeah, it is a projection having some patch, that is adding some weight here, as earlier we have studied. So let us understand what it is and how we will calculate. So now imagine taking a small patch of this image and running a small neural network called as a filter or kernel on it, or say K outputs, and representing them vertically as it is showing in the figure, right? This is vertical, that Y you can see it. Now slide that neural network across the whole image, means we are sliding it entirely the whole image, that filter, right? After sliding it, what we are doing, kindly listen carefully because it is little bit difficult to understand. So after sliding it across the whole image, as a result we will get another image with different widths, heights and depths. We are getting another image with different parameters, we can say. Instead of just RGB channels, we have more channels but lesser width, height. As I have said, with lesser saturation rate, right? So this whole process, we can say this entire operation we have done, is called convolution, right? So if the patch size is the same as that of the image, it will be a regular neural network. Because of this small patch, we have fewer ways, right? So means it is downsampling the things as so. Now let's talk about a little bit mathematics. I know some people didn't like it, but mathematics is my favorite subject, so I feel better while I listen about mathematics. So Even I'm getting excited about mathematics, but don't worry. I'm just explaining you the things that is involved in the whole convolutional process. But theoretically, I'm explaining you. Convolution layers consist of a set learnable filters or kernels having a small width and height and the same depth as that of input volume. Let us consider F3 if input layer is image input. Example, if we have to run convolution on the image with size of filters with the dimensions like 36 by 36 by 3, the possible size of the filters can be x cross 3, right? So where we can be any, where x be anything like we can add 3 5 7, whatever we can give as a x as smaller as compared to the image dimension, right? Means whatever filter we have to add here, that must have to be less than the image size. This is the basic thing. This is the basic mathematics we are using here. We have to use less, dimensions than the image, or we can take it anything, or as per requirement. Now then, a convolutional layer contains a set of filters whose parameters need to be learned. The height, the weight of filters is smaller than the input volume. As I'm saying again and again this thing because this is very important, right? So you have to keep it in your mind. You have to take the dimensions of the filters less than the basic image or input. So each filter is convolved with the input volume to compute an activation map made of neurons. So finally we are saying, this is my most favorite slide in the whole PPT, you can say. Look at that input image line. Yeah, why beautiful. No, it's a handsome, we can say. So we have added convolution layer. You're seeing in the green color here. I've given the different colors so that you can understand it in a better way, right? And then pooling, and then convolution again, and pooling. Then we have flatten, and this is the very important thing, right? That images we have added, and then neurons, and then we have added weights. Then after that we are getting the output, right? So let us understand it deeply, how it is working. I know it's a little bit difficult for the first time if you're seeing this kind of diagram, you can see. But it's still, I'm just explaining it in a very kind way so that you can understand what's happening. I mean, if you understand this thing, then you can easily explain in front of anyone, right? So first we will talk about this convolutional layer. Here, this layer is the first layer we used to unsheath the numerous attributes from the input image. As we can see, there's the image of lion. We are unsheathing the numerous attribute from the lion, right? So we need to collect the information from our data set so that we reach desirable output, right? So in this layer we are applying mathematical operation of convolutional, which is performed in the between the input, that is image of line, and the filter having particular size. We can take it x cross x. Now while sliding the filter across the entire image, we'll take the dot products of the filter and the input image with respect to size of the filter x cross x. So the output is termed as the feature map that provides the particulars of images such as corners and edges. In a while the activation map is fed to for the layers to learn various different features of input image, right? So this is the thing all about convolution, right? So now we will talk about pooling layer, what it is doing here. Generally CNN is followed by the pooling layer. The basic goal of the layer is to reduce parameter of convolved activation function, and also it reduces the computational cost, which is very important thing for us, for the company, for everyone. I think we want the best thing in the lesser cost. So I think pooling layer is very important here because it is reducing the cost also. I mean everything is reducing cost, each layer. So now let's come to the point. Understood? Now let's know how it performs. So pooling layer, we are decreasing the connections between the right, and then what we are doing, we will operate it separately, one by one, on each activation map. So we have to know how many pooling layers are present here. I mean basically there are two types of pooling layer. That first one is max pooling and second one is average pooling. I will brief you about max pooling and average pooling. In max pooling, what we are doing, we are extracting the bigger one or massive via activation map, right? Or on the other hand, in average pooling, we are extracting the average feature of the activation. So I hope you understand. In the max pooling, we are extracting the max features, right? Or in the average, we are taking average features. Itself is describing its own identity, I think. So hope you have understand this pooling very well. Now we will talk about the fully connected layer. Fully connected layer here, what it is doing, it consists the weights and biases accompanied by the neurons which used to connect the neurons between two different layers. Means these layers are generally allocated prior to output layer and construct the ultimate, or we can say rearmost little bit layers of a CNN architecture. Here the input image from the prior layer is flattened and then fed off to fully connected layer. You can say that. Means it is dependent on the prior layer. From the prior layer is flattened and then fed to the fully connected. Now we will flatten the vector, then encounter a little bit more fully connected layers. Not more, we are using just a little bit. Whereas mathematical action generally happening from that point, the classification process comes in the picture. Means where this is the thing where now we will talk about the dropout layer. Usually when all features are connected to the fully connected layer, it can cause overfitting in the training datasets. Overfitting occurs when a particular model works so well on the training data, causing a negative impact in the model's performance when used on a new data. So, for that reason, we have to overcome from this problem. So, we will require a dropout layer, which is utilized where a few neurons are dropped from neural network during training process, resulting in reduced size of the model. And the passing dropout of 0.3%, that is said to be 30% of the nodes are dropped out randomly from the neural network. That is not important. We will take another digit like 0.25%, that is 25% of the nodes are dropped. Now we will discuss about the last layer. Finally, this last layer that is activation function. Basically, what it is, we have to understand that, and further we will describe it in detail. So, the activation function compares the input value to threshold value. If the input value is greater than the threshold value, then the neuron is activated. It's disabled if the input value is less than the threshold value, which means its output is not sent to the next hidden layer. Means basically it decides which information of input needed to fire in forward direct and which shouldn't at the end of the network using mathematical operations. Right? So after that, now we will come to the that picture. Here we have eyes of the lion, means we are taking little bit features from our data set, what we have, and what is the input, that is lion, and we are taking the eyes of lion, taking the hairs of horse, and then eyes of lion, and there's a face of, I think, tiger, it is showing well, and then again we having hairs of lion, and then last one drawing tiger, right? So these are the features we have collected by which we can understand which picture we have. So we have three neurons, on the basis of neurons we have to add the weight. This is very important. So number of neurons directly proportional to, we can say, number of weights, right? So we have added 0.2 for the first neuron, for the second neuron 0.7, for the third neuron we are giving weight as a 0.1. Like as in ANN, this process from the flat ANN to the weight, including that neuron and pictures, this is said to be ANN, artificial neural network, right? This process. So the formula used here, Wx1 plus Wx2 plus Wx3 is equal to output, right? This is the mathematical formula. So here we are using that, and now what we are getting the output. First one is horse, means there is a chance, probability of becoming the horse, as he's also having long hairs, right? So, and the next probability will lion, and the last probability will tiger, because these three are in our data sets. So the highly probability is here with the lion. So yeah, finally it reads it as a lion, right? Finally, right?